Hello, it's Mr. Sarisa, and I want to do another practice problem where we're analyzing and graphing a conic through a polar equation. And so the equation I want to do right now is r equals 12 over 4 plus 8 sine of theta. And so the first thing that you really should notice is that this number is not a 1. So 4 is not equal to 1. So make sure you understand that. And then we have to put it in the proper form where that is a 1. So the best way to do this is to factor out a 4. And so I'll factor that 4 out and get 1 plus 2 sine theta. And so once I do that, I see 4 goes into 12 3 times. So my final equation will be 3 over 1 plus 2 sine theta. And then I look to see what E is. And E in this case is going to be 2. So that right away, that's greater than 1, so that's a hyperbola. And so I have an idea of what it looks like. Now I need to see where it's going to be positioned. And the plus sign tells me it's going to be above the pole. And since that's above the pole, that also tells me that theta equals pi over 2 is the transverse axis. And so right away that tells me where I have to go to look to see where the vertices and the foci are going to be. And so let's start doing a little bit of drawing on this now, just to get it started. And so I know this looks like a rectangular plot, but that's only because I don't want to draw the zeros. So this is the polar axis, and this is the theta equals pi over 2 axis. We know that the one focus is always going to be right here at the pole. So I'm just going to say that's F1. And then we need to find out where the directrix is going to be. So we'll come back over here. And say, oh well, EP, which actually now that we know E is 2P, and that equals 3, which means P equals 3/2. So that's telling me the directrix is going to be 3/2 above the pole. And so I'm going to mark these out, and so I'm going to go by 2's. I think that'll be easier to see. So we have those there, going 1 through 4, and like I said, it's 1.5 above the pole. So let me draw that in. Here's the directrix. Now don't confuse the directrix with either of the axes. It has nothing to do with the axis, transverse, or the conjugate ones. It's just there. But the transverse axis is going to be perpendicular to the directrix every time. So you can count on that. And so seeing that the transverse axis is going to be theta equals pi over 2, I'm going to find out where the vertices are by plugging in pi over 2 into our equation. So I plug in or plug in the pi over 2 for theta, and then we have 3 over 1 plus 2 sine of pi over 2, of course, is 1. So this actually makes things really easy for us. That's 3 over 3, which is 1. So one of our vertices is going to be 1 pi over 2. And then the next one, we also, it's basically the same line, but we'll use theta equaling 3 pi over 2. And so we're plugging that in. So we plug that in, and of course, sine of that will be -1. And so that's times -1, so that's 3 over -1, which is -3. So that vertex is going to be -3 pi over 2. And actually, if you remember back when we started doing polar coordinates, this is actually the same thing as 3 pi over 2. Right? So we have it just going in the opposite direction, but it ends up at the same point. So let's put down those vertices. So we have one at 1 pi over 2 and 3 pi over 2. Those are the two vertices. And then right in between those two will be the center. So this is pretty easy figuring it out here. Normally you just take the average, but the average of 3 and 1 is 2. So we'll mark our center right at the 2. Okay, and you can just see that graphically. That's, even a better, more intuitive way of doing it. But otherwise you would just take the average of them. Alright, and so now that we see where the center is, we can use the focus that we already have, and then that's 2 away from the center, so 2 away from the center in the other direction is going to be the other focus. And so now, if you look at it, what we really know is we know A and we know C, right? So A, of course, is the distance from the center to the vertex, and that's only 1 away. And C is the center to the focus, and that's 2 away. So we can calculate out what B is going to be. And so we know B squared equals C squared minus A squared. So that's going to be 4 minus 1, which is 3. But we can't use B squared in this case. We need an actual B because we're measuring out the box in order to make the asymptotes. So B will be radical 3, which is, well, approximately 1.73. And so what that means is, on our graph, starting at the center, we're going to go up A, but then over 1.75. So let me just draw these in, because we're going to go both directions. And so let me put that in. So we go from the center, that's where the 2 is. We went up 1 and then over 1.75. So that's approximately here. And then we'll do the same thing on the other side, about here. And then we'll also, we have to go down that amount along the side of the other vertex. So there's our 4 corners of the box. And I'll just start drawing these through. Nope, that was pretty good. Alright, here's our asymptotes that we're drawing in. And then we just draw our hyperbola. So we'll just start here near the asymptote, go through the vertex, and then come close to the asymptote. Same thing on the other side. And then there we go. So that's it. This one was particularly easy. The numbers worked out really nicely, but they don't always work out nicely. So look out for that and just be very careful with just the arithmetic skills, finding the center. That can be a challenge. So I hope that this helped. Thanks, and I'll see you in the next one.